Hello, how are you doing? Today we learn about convolution, the operation, another operation in mathematics. Just interesting operation. We start our journey with the precise definition what convolution of two function is. If f of t and gt are piecewise continuous on 0 up to infinity, that means f and g are piecewise continuous, mean continuous except at a finite point in its domain, then the function may possesses a jump discontinuity, which means then the convolution of f and g is defined as from 0 to infinity, t f of x g of t minus x dx. We introduce new demi variable x here. We have the original function as f of t, but here is f of x g of t minus x dx. So that this is the formal definition of what the convolution of two functions is generally, so that we can compete using the precise definition whichever you happen to encounter two arbitrary functions which are actually a piecewise continuous function on the half real line here. Let's say if we ask you to find the convolution of two functions 1 and t, 1 is another function, g of t is also other function, so we apply the definition from 0 to t f of x g of t minus x dx. This is the formal definition for any function, two arbitrary functions here. So in this case, f is 1, g is t, from 0 to t of f of x, mean if f of t is 1, f of x is 1 still, because f is constant here. So if f of t is 1, f of x is still 1. So we put 1 under the integral, again t, since the function f of t itself is outcomed, so f of x is again fx, you mean f of p is p, so f of t minus x, you mean in here is t minus x. Okay, so we have t minus x under the integrand. We make integration with respect to x, not with respect to t, so t with respect to x is tx, x with respect to x integration is x squared over 2. Then you assign specific value from 0 to t mean at x equals to t, at x equals 0 we mean. So we have if x is t squared over 1 minus t squared over 2, where at t equals, at x equals 0 is nothing, just 0. So we have t squared over 2 through algebraic manipulation. Therefore, one convolution t is t squared. Okay, so we use the definition. Again, we have another instance. We have f of t is e raised t, g of t is sine t. Through definition, we have f convolution g, mean from 0 to t as usual, like we did before. So f of x mean g of, e raised x here. Since g of t is sine t, g of t minus x we mean replacing t by t minus x, and the assigning here what g is already assigned as sine t. That's why g of t minus x mean instead of t we replace t minus x, so that we have e raised x sine t minus x. So it needs computation. The making integration, compute the integration of here, e raised x sine t minus x. I think it's free to apply other many techniques where we compute the integration here. You have already familiarized with multiple techniques of integration, but here let me show you that sine t minus x can be written as imaginary of e raised I t minus x from the Euler's formula, Euler's identity. We mean e raised I theta mean cos theta plus I sine theta, you mean. So they just turn it to the complex number, and the relationship, a correlation between complex number and the exponential function. So it just emanated from that relation. We got imaginary e raised I t minus x dx, So that we have imagined from 0 to t, erase x, erase it minus ix dx. That's why imagine it can be an interpretation, so we can move out of the integration. We first doing the, I just summed up the exponents here due to the same base here that we did several times. So we make substitution for this, letting this is u or p and so like. So we get this. Then finally assign specific value at x equals to t, at x equals to 0 we mean. So that we have imaginary of this, imaginary at x equals to t mean t, then at x equals to 0, we just going to put here if x equals to t mean t plus it minus it is 0, so erase t remains. That's why we have erase t in this case. So that's matter we will just do it. We seeking for assigning specific value here at x equals 0 against up. We get this. So we have expanded to the cosine and sine. This is it mean from the Euler's identity. We get this. We have to be rationalized. While you rationalize, you have to multiply both numerator and denominator by its conjugate. For 1 minus I here, the denominator, so its conjugate was 1 plus I over 1 plus I. So, good. We need multiplication here individual. That's algebraic manipulation, extremely elementary. We make distribution, then we get this form. Then 1 minus I times 1 plus I mean like a minus b, a plus b, a square minus b square. So that's a square minus b square, 1 square minus I square mean I square is square root of minus 1. Then plus 1, so it becomes 2. So we have here the exponential function, I mean the convolution of irresistible sign t is this. Now let's proceed to the convolution theorem. Very powerful theorem, especially in finding inverse Laplace transformation. You have been addressed how to find the inverse Laplace transformation previously using standard formula, using basic property, using the partial fraction decomposition, using complete square method. The other method is convolution theorem. It asserted that assume f and g have Laplace transformation, therefore Laplacian of f convolution with g mean f of s g of s. So Laplacian of f convolution with g mean the Laplacian, the product of individual Laplace, the product of their individual Laplace transformation we mean, or making inverse in both sides, applying or playing the inverse role. In here we get Laplacian inverse mean this identity, so that we get here. So Laplacian of inverse this mean just return it back to the original function with its convolution, so that we can apply convolution in finding inverse Laplace transformation also, rather than the previous methods. Possibly we can also apply convolution method in finding inverse Laplace transformation. I think it's pretty easy to understand once we have been formulated in this form. So that's clear to understand that, let's say if you assume you valid Laplace inverse of 1 over s squared plus 1 then square, this can be written as a product of two functions. Usually while you encounter it and seek for finding inverse Laplace transformation using convolution, you have to write that function you got into two product functions if it's possible. So that is you can apply convolution theorem directly. So in here, fortunately, we can write 1 over s squared plus 1, 1 over s squared plus 1. That's entirely gives 1 over s squared plus 1 square. So we have f of t is this, because f of s is here. Again, this is g of s. Fortunately, we have the sum. So the inverse Laplace transformation of f of t means this sin t, and Laplacian inverse of g is also similar. So g of t. So using convolution theorem, Laplace inverse of 1 over square plus 1 mean Laplace inverse of f of s, g of s here in the upper. So that we can use f convolution g, since f and g are already discovered through the inverse Laplace transformation from the previous method. We have sin t convolution sin t. So ultimately we seek for the convolution of the two functions here. We have the same function, it doesn't matter. So sin t convolution with sin t means sin x, sin of t minus x dx. We apply the convolution method using convolution. So we have 1 over 2. Again, this mean from the trigonometric identity sin a sin b mean half cos a minus b minus cos a plus b, you mean. Okay, so that this will be turned to, let's say if this x is a, this is a minus b, so a minus b mean 2x minus t. Again, a plus b mean x is 0, so t then for cos a minus b minus cos a plus b, we mean. So finally we have here the integration, because this was integration of this mean integration of this term wise integration you can apply directly, it's possible. So making integration using substitution rule, we get this form, half of sin 2x minus t over 2 minus x cos t at 0 and t. Therefore half of sin t over 2 minus t cos t minus sin of t minus t at t is equal 0 here. If t is 0, then 2t minus t is sin t over 2 minus if x is t, then t cos t. Then minus with this barrier, you go to a sign for x equals 0, directly sin 2 times 0 is 0, sin of minus t over 2, minus if x is 0 is here 0. Because this is odd function, naturally the sine function, minus sin of t minus t is sin t over 2, similar. So we have the 2 sin t over 2, then addition of 2 is sin t of the function, So we have minus t cos t would be the final answer using convolution method. So convolution method generally is very powerful, especially in finding the inverse Laplace transformation. As we asserted in the theorem, the Laplace of f convolution with g mean big F of s times big G of s, or Laplace of f of s, Laplace of g of s, we mean. That means we have already making this formula, we mean using the formula of the convolution theorem, which is very powerful with this theorem in finding inverse Laplace transformation. So I think it's pretty easy to understand what convolution theorem and convolution generally. If you have questions, you have to be subscribed the channel, so that problems, questions you can send questions to my channel or as a comment, so that I will revise the topic.